Classification of the real number system. Numbers can be classified into two categories, real and not real. Real numbers can be rational or irrational. A rational number is any number that can be written as the ratio of two integers, which consequently can be expressed as a terminating or repeating decimal. Irrational numbers, on the other hand, are numbers that cannot be written as a ratio of two integers. Rational numbers have subcategories. One subcategory of rational numbers is integers. The other subcategories will be explained later in the podcast. In order to understand rational and irrational numbers, we need an understanding of what an integer is. Integers are positive and negative whole numbers and zeros such as -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. Integers do not have any fractional parts, so numbers such as 1/2, 0.3, 2 1/4, and 25%, etc. are not integers because they involve fractional parts. When determining if a number is rational, the number must be able to be written in such a way that the numerator and denominator is a positive or negative whole number. The numerator can be 0, but not the denominator. We'll talk about that later. Let's look at some examples of rational numbers. The square root of 25. Since the square root of 25 is 5, and 5 can be written as the ratio of two integers, 5/1, this number is rational. Note that it can be expressed as a terminating decimal of 5.0. 1/4. Since this number is already written as the ratio of two integers, 1/4, this number is rational. It can also be expressed as a terminating decimal of 0.250. 20%. Since this number can be written as the ratio of two integers, 20/100 or 1/5, this number is rational. It can be expressed as a terminating decimal of 0.20. 1/3. Since this number is already written as the ratio of two integers, 1/3, this number is rational. It can also be expressed as a repeating decimal of 0.3333 and so on. -8. Since this number can be written as a ratio of two integers, -8/1, this number is rational. It can be expressed as a terminating decimal of -8.0. -2.5. Since this number can be written as the ratio of two integers, -5/2, this number is rational. It is already expressed as a terminating decimal of -2.50. -1 times the square root of 36. This number can be written as the ratio of two integers. Since the square root of 36 is 6, and when negated is -6, -6 can be written as the ratio of two integers, -6/1. Additionally, observe that -6 can be expressed as a terminating decimal of -6.0. 0. Since this number can be written as the ratio of two integers, 0/1, or over 6, or over 5, or 0 over any number, this number is rational. It can be expressed as a terminating decimal of 0.0. The set of rational numbers has subsets. Some common subsets of rational numbers are natural/counting numbers, whole numbers, and integers. Some numbers fall into more than one category. Natural/counting numbers are positive whole numbers beginning with 1. A way to remember natural/counting numbers is to think about what number you begin counting with. 1. So natural/counting numbers are numbers such as 1, 2, 3, 4, etc. Whole numbers include all counting numbers and 0. So whole numbers are 0, 1, 2, 3, 4, etc. Integers were explained previously, but recall they include all natural/counting numbers and whole numbers. They are positive and negative whole numbers and 0, such as -4, -3, -2, -1, 0, 1, 2, 3, 4, and so forth. Rational numbers were explained previously, but recall they are 0 and all positive and negative numbers that can be expressed as a ratio of two integers, with no 0 in the denominator, including integers, whole numbers, and natural/counting numbers. Irrational numbers were also explained previously, but recall that they are real numbers that are not rational and cannot be written as a ratio of two integers. Let's take a look at some examples of irrational numbers. The square root of 20. 20 is not a perfect square that is an integer, and when the square root of a non-perfect square that is an integer such as 20 is calculated, the result is a decimal that cannot be expressed as the ratio of two integers. The square root of 20 is 4.47213594, and so on, without any terminating or repeating decimal parts. Pi. People have calculated pi to over 1 million decimal places, and still there is no pattern, suggesting that the decimal does not repeat or terminate. The first few digits look like this. Mathematicians have proved that this number cannot be written as the ratio of two integers and is therefore irrational. Here's an interesting fact about irrational numbers. Anytime you divide an irrational number by an integer, the result is also an irrational number. That might surprise some people since it can be written as a fraction. For example, the square root of 3 is known to be irrational. Therefore, if we divide it by 2, the resulting number is square root of 3 over 2, which is also irrational. Its decimal representation is non-terminating and non-repeating, but it begins with 0.8660254 and so on. Keep in mind, though, that irrational numbers are considered real numbers. The real number system can be divided into two categories, rational and irrational. Many students tend to think that irrational numbers are not real. This is not true. Irrational numbers are real, but they are just expressed differently than rational numbers. Basically, in order to determine if a number is real, ask yourself if the numbers can be placed on a number line. If the number can be placed on the number line or be ordered, then the number is real. For example, the following numbers, -1 times the square root of 3, square root of 35, 2.5, -6, -4.2, and square root of 16 can be placed on a number line. -1 times the square root of 3 is almost -2 because -1 times the square root of 4 is -2. The square root of 35 is almost 6 because the square root of 36 is 6. 2.5 falls between 2 and 3. -6 falls on -6 on the number line. -4.2 is a little less than -4. The square root of 16 is 4, so it falls on 4 on the number line. There are some numbers that do not fall into the category of the real number system. Those numbers are considered not real. Essentially, they cannot be placed on a number line. For example, consider x squared equals -1. In order to solve for x, you have to take the square root of x squared and the square root of -1. There is not a real number that is the solution to the square root of -1. This is because there are no two identical factors that when multiplied together will equal -1. Hence, another interesting fact, the square root of any negative number equals a number that is not real. Additionally, let's examine numbers whose denominators are 0, such as 3 over 0, -7.3 over 0, and the square root of 18 over 0. These numbers are undefined, and because 0 is in the denominator, they cannot be considered a real number. They are really not numbers at all. So let's practice and see if we can classify the following numbers. Remember that some numbers will be placed in more than one category. -5. -5 is an integer and also rational. 7 over 0. Because 0 is in the denominator, 7 over 0 is a number that is not considered real. Remember, it really is not a number at all. 18%. It is only rational. 8 squared. 8 squared's equivalence is 64, and 64 is a natural/counting number, a whole number, an integer, and a rational number. 26. 26 is a natural/counting number, a whole number, an integer, and a rational number. The square root of 121 over 3. Its equivalence is 11 over 3, which can only be classified as a rational number. The square root of negative 25. Recall that the square root of any negative number is a number that is not real. Negative 1 times the square root of 67. Negative 1 times the square root of 67 is irrational because it cannot be expressed as the ratio of two integers. Negative 2 over 3. It is rational only. Negative 2.73 with the 0.73 repeating. It is rational only. The square root of 20 over 2. Recall that any time you divide an irrational number by an integer, the result is also an irrational number. So the square root of 20 over 2 is irrational. 1/3. It is only classified as rational. And 0 over 20. Since 0 over 20 is really just 0, it can be classified as a whole number, an integer, and a rational number.